Okay, so we're going to learn about dimensional analysis here to kind of continue on what we were doing before. And so what this represents is some water that has dripped out of a tap, and we let the tap drip for 30 seconds. Okay, let's just make sure we got what we need. We let the tap drip for 30 seconds, and we did it with a watch that has a seconds hand, and so it's 30 seconds plus or minus 1 second. Okay, and this is the amount of water that dripped. Okay, and in order to read this, we have to understand that this goes up in increments of 0.2 milliliters. Okay, so 4.2, 4.4, 4.6, 4.8, and we can see that this lies somewhere between 4.2 and 4.4, and I use a little bit of estimation there, and I get 4.3 plus or minus half the last readable digit milliliters. Okay, and what we're going to use this for is a little bit of an experiment, which is going to say how much water drips 1 year. Okay, and in order to do a problem like that, we need to, and I'm going to say I want it in liters. Okay, and the next question is, how much money will that cost? And I'll have to go look at what water costs here, but I know that it is measured in cubic meters. So we're going to have to do a conversion there. All right. So a problem like this requires lots of conversions, right? There's a lot of seconds in a year. How do we deal with that? Milliliters and liters are related, but how? How do we convert one into the other? And you'll see pretty quick in physics, you run across problems of this type a lot. So we're going to put in place a system that helps you deal with this type of thing. And by the way, this is read from the bottom of the what's called the meniscus. We don't often use graduated cylinders in physics. Maybe there's some experiments where we would, but it definitely in chemistry you do. You've got to read right from the bottom of the water. That's kind of how that's done. Okay, so that's our kind of background problem. The tool that we use to solve something like this, did I spell that right? No, I did not. Holy smokes. Dimensional analysis. Wow. Dimensional. Now, dimensional analysis can get to be fairly robotic, right? And that's definitely not what we want to have happen. I don't want to be doing this robotically. I want you to be thinking about what you're doing all the way along. So the first example we'll make as simple as we can. Example 1. Find the number of seconds in 1 day. Okay, you may have seen this method, you may not have. If you haven't, here's a bit of a review. So what we want to do is we want to take the value of 1 day, and we want to break it down, or we want to expand it out into the number of seconds that is the equivalent of. So how many seconds there are in a day? So I like to write out what we need here. Now you're going to need some conversion factors along the way, right? We know that 1 day is exactly the same as 24 hours. We know that 1 hour is exactly the same as 60 minutes. And we know that 1 minute is exactly the same as 60 seconds. Another way to say this, if you want, is to write it as ratios, right? Essentially 1-to-1 ratios, right? 1 day is the equivalent of 24 hours, or there's 1 day per 24 hours, or 24 hours per 1 day. It's kind of, if you want to understand math-wise, I guess it's like saying these are both true, right? So that's kind of that's sort of what we're doing here. We can write these both ways because they are equivalent to one another, exactly 1-to-1 ratios. Okay, so these little fractions, if you want, that we have here can also be written like this. We could write 1 day actually, let's not confuse you. We'll just leave it like this for now. Don't worry about what I was just going to do there. Yeah. So we're going to use these things. These are called conversion factors. And since you can invert them, they can be used as follows. So we're going to say 1 day, and the first thing we're going to do is we're going to convert it into hours. So there's 1 day, and there's 24 hours for every 1 day. Oops, that's not right. 24 hours for every 1 day. So what we're basically saying is this is the equivalent of 24 hours. You look at the math here, you get 1 day, 24 hours on the top divided by 1 day. So in other words, the units day would cancel off here. So dividing them off. Okay? Okay, so that's 24 hours. Then the next step is let's get 24 hours into the next unit down. So 24 hours, well, in 1 hour, there's 60 minutes. So go through that. Okay. This works out to be 1,440 minutes. Okay, and some of you probably already know, well, there's 3,600 seconds in an hour, but we're going this route, so. And in 1 minute, there are 60 seconds. So 1440 times 60 minutes cancel off. And that works out to be 6,400 seconds in 1 day. Okay. So this is essentially the method that we're going to use. Let's do one more quick example before we tackle our problem here. Okay. So this is to deal with the scenario when you have two units kind of working together. So the classic example is a velocity. So let's say we have 120 kilometers per hour, and we want to know what that is in terms of meters per second. Okay. So I kind of like to do a similar concept, and pick one or the other that you're going to deal with first. 120 kilometers is the same as 1,000 meters, right? So our conversion factor is 1,000 meters is equal to 1 kilometer. That's the top one. And 3,600 seconds is equal to 1 hour. That's our other conversion. So we kind of do this in, I would say, in 2 steps. So we have 1,000 meters for every 1 kilometer. That's going to deal with the top. We're not dealing with the hours here, and it's just 1 times 1, so it stays the same. Kilometers will go away, and we'll get this 120,000 meters every 1 hour. Okay, right? And then take that, and we know that 1 hour, for every 1 hour, there's 3,600 seconds. So we're converting the bottom now into its equivalent in seconds. We have 120,000 meters every 3,600 seconds. So essentially now you see that we've got our units canceled out in such a way that we end up in the units that we want. Meters on the top, seconds on the bottom. It's just a matter of now reducing this fraction down to what we need. So 33.3 meters per second. if we want to obey sig fig rules, we can only have 2 significant digits here. Technically, really only 1, but that'd be a little silly since 1 hour is given. So we'd round it to 33 meters per second. That's a pretty good answer there.